Okay, so let's go over this. So from the problem, we should have identified that this is 97, this is 17, this is 35. And these are 102, 15, 27. When we plug all of this in, we would have 97 minus 102 plus or minus t star times 17 squared over 35 plus 15 squared over 27. Our t star, how many degrees of freedom do we have? We use n minus 1, so I have 26 degrees of freedom. I do 27 minus 1. I have 26 degrees of freedom. 90% confidence, 26 degrees of freedom, I have 1.706. Okay? So 97 minus 102 is negative 5. And I get 1.706 times this thing. .073 times 1.706, and I get negative 5 plus or minus 6.95. I'm getting 6.95, but in your rounding you got 6.94.
Yeah.
It's not that big of a deal.
Okay, cool.
You have a question?
Yeah, if you switch, because I asked you for switch, and I switched it and I got.
You got 5 plus or minus 6.95?
Yeah.
Okay, so anyway, I have negative 5 plus or minus 6.95, and I get negative 11.95 to 1.95. Conversely, if you switch 102 and 97, then you would have 5 plus or minus 6.95, and that would be negative 1.95 to 11.95.
And do we switch it or not?
No, I don't recommend it, but we can talk about what these things mean. Alright, so let's look at this one. So this is my confidence interval, negative 11.95 to 1.95.
Just change that to
Huh?
You change it to a 5 and negative 5?
I'll deal with this later. Okay. So I would say I am 95% confident. Or I'm sorry, 90% confident that the average IQ of males is between 11.95 points lower and 1.95 points higher than females. I'm sorry, higher than the average IQ of females.
Mr. Chen?
Yes.
Or can we write, like for example, I will, the difference between average IQ of males and females is 5, give or take 6.94.
Okay, that's fine. I prefer this
Okay.
form. Okay, but that's also fine. So I write I'm 90% confident that the average IQ of males is between 11.95 points lower and 1.95 points higher than the average IQ of females. Is that good?
Okay.
So do we have evidence that there's a difference between the average IQ of males and females? Okay, what do you think? What is our answer?
Yes.
The answer is no, because 0 is in between negative 11.95 and positive 1.95. So 0 is a potential answer for the difference. And if 0 is the difference between the average IQ of males and average IQ of females, then there is no difference. The answer is no. 0 is within the interval. So we do not have evidence of a difference.
Just make sure it's negative 11.95 on the top.
Yes.
Or, no, when you wrote the actual sentence, you just left it as a positive number.
No. Oh, lower? Because I said 11.95 points lower.
Alright.
Yeah. Alright, is that okay? If you had to swap them around and you called this one sample 1 and this one sample 2, then your answer would be 5. Would be 5 plus or minus 695. Okay, let me talk here.
I'm sorry.
If you did 102 minus 97, and I generally recommend that you do the first sample mention as sample 1 and the second sample mention as sample 2. But if you decide to switch them around, then you would have 102 minus 97, and it would be 5 plus or minus 6.95. Everything else would actually remain the same. You would have 5 plus or minus 695. And your confidence interval would go from negative 1.95 to positive 11.95. How would this change? Our answer would then switch to, I am 90% confident that the average IQ of females is between 11.95 points higher and 1.95 points lower than the males. Okay? So we're saying the same thing. One is we're saying, I'm confident that males are between this much and this much higher, or in the other case, we'll say, I'm confident that females are between this much and this much higher or lower. So we're just swapping the numbers around. I can say, this thing is taller than this thing, or I can say, this thing is shorter than this thing. We're saying the same thing. And that's all that happens when you swap the two groups. Okay? Alright. I'm going to keep going here. Now we're going to deal with the confidence, not confidence intervals, hypothesis tests.
I'm sorry, what are we doing right now, Christian?
I'm going to keep going.
Oh, no, okay.
So we have hypothesis tests. Now it's a hypothesis test. We're going to have one sample, a numeric variable, and many times this is known as a t-test because we're using the t-table. So just like hypothesis tests for proportions, when we were dealing with categorical variables, here we're going to have to come up with a pair of hypotheses. So we have a null hypothesis. And it would be H0. And the null hypothesis is always in the form that mu is equal to some number. Let's say, in this case, we're going to say, I don't know, 23. And then the alternative hypothesis is that mu does not equal 23, or whatever number it is, okay? You can also have, also possible is the alternative hypothesis that mu is greater than 23, or that mu, the population mean, is less than 23. Okay? And this depends on how the problem is written. When you do a hypothesis test, okay, from your data, when you have one sample, you need x bar, s, and n. You calculate your test statistic. Your test statistic is going to be a t-score. And that's going to be x bar minus, and I write mu 0, or basically the mu, the number that appears in your null hypothesis, divided by s over the square root of n. And you take the test statistic, or your t-score, and look up the corresponding tail area in the t-table. Next question.
Mr. Chairman, says t equals x bar minus mu 0.
Yes.
What's mu 0?
Mu 0 is whatever number appears in your null hypothesis.
Wait, so what is next to the mu?
A 0.
The zero.
So mu 0, mu 0 is the number in the null hypothesis. Null hypothesis is often called H0, so that's why we call it mu 0. Or HO. So you look up your test statistic in the t-table to get your tail area. And your tail area is your p-value if you have a one-sided test. Do you remember what a one-sided test is?
One sample. One sample.
No, not one sample. One-sided test means our alternative hypothesis has HA has greater than or less than. Your p-value is equal to 2 times your tail area for two-sided tests. In those situations, the alternative has this should sound somewhat familiar based on what you did last week in your chapter 8 homework. We take our p-value and we compare it to what? P-value compared to alpha. And if our p-value is greater than alpha, what do we do? We do not reject the null hypothesis. And if the p-value is less than alpha, we reject the null hypothesis. So that is the process that we follow for a hypothesis test with one sample and it's a numeric variable. Yeah. Yeah, let's do an example then. Or do you guys need another minute to calculate all this stuff?
Yeah.
Okay.